The following is a tutorial on how to manually tune the current direct and quadrature loops of your servo drive with the Tune workspaces. This tutorial is based on MotionLab 3 version 135 and firmware version 152. So if you're not using these particular versions, you might experience some slight changes on the features of the graphical user interface. Now, performing a manual tuning or fine-tuning of the current loops with the Tune workspaces is quite a straightforward process if you have already configured the feedback sensors in your system, either in the wizard or outside of it. If you have not configured your feedback sensors correctly, specifically the reference and commutation sensor, you might experience some issues while trying to do the manual tuning, which can lead to abnormal behavior. In such case, a couple of additional steps should be performed before trying to access the Tune workspaces and try to tune the loops. These exact changes that need to be done are the following. And by the way, these changes can either be done in the Drive Explorer or the control. But in this case, we're going to use the Drive Explorer. The parameters that need to be changed are the following. First of all, as we have said, if you don't have the commutation and the reference sensors properly configured already, you will have to change them. And you will have to change them to a value of 3, which means that you're going to be setting them to the internal generator so that there's no external sensor that you have not even configured try to commutate your motor. In addition to this, what you're going to be configuring as well is what type of generator you're going to be using. And that is done by setting a register called generator mode. And you need to set it to 0, which means constant. What this will do is it will halt the motor in one particular position and it will not move, so that you can perform the tuning in that particular position without the motor vibrating or moving and getting out of control. Once you have implemented these changes, you can go directly to the Tune workspaces and go ahead and tune one of the loops. Since both the current direct and current quadrature need to have the same PI gains, you can simply tune one of the loops and copy paste the gains that you have found that give you a decent performance to the other loop. In our case, we're going to act as if we start from the beginning, so gains all to 0. And basically what you're going to have to tune are the KP, proportional gain, KI, integral gain, and KR. KR is a gain that is used to change the control scheme of the loop. It's a gain that can range from 0 to 1, its value, and with 0 being an I plus P type of controller, and if you set KR equal to 1, it will be a PI controller. In our case, we're going to be using KR equal 1. Now, once you have set this, you can go ahead, well, you can set first the signals on your signal generator. In our case, we're going to use the default ones, but if somehow the amplitude of 2 is already too many amps for your motor, you can lower it, and you can also change the frequency if you want to, and so on. Now, once the signal generator parameters are fine with you, you can click Enable, and this will basically start plotting a signal. You will see here the demanded signal in green, which is the signal that the signal generator is basically plotting, and you have the actual value of the current in orange, which is the signal that you're going to try to tune to feed the green line. In our case, then, what we can try to do is a pretty straightforward process that should allow us to tune the loop. What this procedure is basically you first start increasing KP, and you increase it until you reach a point in which there's no difference between the steady value of the actual value. It doesn't get closer to the demand value. Once you get to that point, it will basically mean that the signal will not get any closer, and you will have to add some KI gain into the equation. As we can see, it's starting to get very close. So what we can do now already is start adding integral gain until we see that it reaches. And do not hesitate to write some larger gains, because sometimes this is what's required. So as we see, the steady value is starting to increase and approach the demand signal until we reach something that we can accept probably as a good performance. Probably not get carried away unless we don't want to get overshoot or excessive oscillations. And now that I have some gains for the quadrature loop, what I can do is take these gains directly and tune them directly to the other loop. So in this case, the current direct loop, I will also type in 0.5, 2001, and if I enable, I should see a very close performance, since the loops have the same gains. This is all for this video, but if you want to learn more about how to use MotionLab 3 to configure your servo drives, please do not hesitate to check our MotionLab 3 series of YouTube videos, and also do not hesitate to check out our website.